if you guys recall, thinking about this kind of the long way is thinking about x to the fourth is on top, and there's a single x on the bottom. So where are there more x's? On the top. How many more? 3 more. So we would say this would be x to the third on the top of the fraction. Now technically, if you didn't write a fraction at all, that's going to be fine. We'll get to that in a second. But that's where there's more x's, they're left on top, there's 3 more of them. How about the y's?
More on top.
More on top, how many more? 4. And again, the bottom would just cancel, so it'd just be 1. So technically, this could just be written this way. So just remembering that rule about subtracting the exponents when we're dividing. However, like in number 2, the 12 over 4, we don't subtract that, we just simplify that. What is 12 over 4? 3. And then how many m's am I going to be left with? 2. All right, so being comfortable with this, like I said, we're going to use this quite a bit today. And then number 3, what happens? We're just left with a b. The 6's cancel to be 1, so if you want to call it 1, you could. Otherwise, you could just say we're left with b to the first, or just v. Again, or 1b if you want, but knowing that everything else will cancel. All right, so the first example is hopefully to get you thinking about the second. I think a lot of times looking at it as real numbers versus variables kind of helps a little bit. So if it says when 6,454 is divided by 632, the quotient is 17. Find the remainder, and hopefully I did my math correctly. Sometimes I'm halfway through a problem and then I start doing something else, but yes, I think that is. What would the remainder be? Do you guys remember how we figured that out?
17 times 362, and then subtract what else you have.
Yeah, so we basically multiplied 362 by 17. And we subtracted it from like the original. That would give us what the remainder is, like how close did we get to actually getting 6,454. And it's not really all that close, but so we're 300 short, right? So the remainder is 300. That's going to help us, I think, with like this algebra now. So it says, when this long polynomial is divided by x squared minus 2, the quotient is this. So they want us to find the remainder and the degree of the remainder. So when I divided the x to the 8th thing by the x to the 2nd thing, my answer is the x to the 6th long polynomial. Find the remainder. We're going to do exactly what we did up here. So what 2 things I'm going to start by doing? Just think about it as the numbers. We're going to end up subtracting, but what do you have to do first? Yeah, we're going to have to multiply. So in order to kind of do this process, we're going to multiply the solution, or what we're dividing by the answer. So we're multiplying those 2 together, and then we have to subtract it from the original. So a little bit of a pain to multiply this, but there's not going to be a ton like these. Multiplying those 2. Just be careful with your sign, or I guess there's only a few negatives there, but be careful about adding the exponents and that kind of thing. So I'm distributing here. And remember, you add the exponents as you go. Through multiplying, we add those exponents. So far I did this x squared times everything. Now I have to do the negative 2 times everything. Now we're not going to leave it this way, we're going to combine some like terms. These x to the 6's cancel, right? So now 3 minus 4 9 minus 6 So this is what I got when I multiplied those two together. Remember, we did this just a second ago. We multiplied them together, but then we took it away from what we originally divided by. So now I'm going to bring this down. So this, I'm going to bring down to subtract these two. So I'm going to take this away. Now careful here, a lot's going to cancel. We have x to the 8th minus x to the 8th. Those cancel. A negative x to the 4th minus a negative is going to become plus. So those are also going to cancel. 3x squared minus 3x squared also cancels. And my remainder is just negative 5 minus a negative 18. As long as I trust my math here, so we get 13, right? So my remainder would be 13. What's the degree of that remainder? What's the degree when there's no variable at all? It's 0, yep, the degree would be 0. Because it'd be like x to the 0 power. Doesn't need to be written. So, like I said, we're not going to do a ton like this. This is kind of a long and involved problem, but at the same time not impossible. But the idea is there, that we understand where the remainder is kind of coming from and what it's there for, hopefully to help you see that a little bit more. All right, now we're going back to like, I don't know what grade you learned this in, like 3rd grade or something. We're doing long division. Because if you don't know how to do regular long division, polynomial long division is impossible. So we're doing long division with this 4-digit number and the 5 here. So remember our little division bar that kind of looks a little like a square root, but isn't. Now, if you don't remember this, here's your quick tutorial of, like I said, I don't know if it's 3rd grade, what grade it is, but. So we start by looking to see how many times does the 5 go into the 7. So 5 divided into 7, how many times does that happen? Once. So I put a 1 up here. I'm going to multiply here. So I'm going to kind of write some steps over here. So I'm going to divide first. Then I'm going to multiply the 1 times 5 together. What's my next subtract? I was going to say next step, and then I was going to say next subtract. Subtract. So 7 minus 5 is 2. And my next step is to bring down that next little number. So the 2. You could bring them all down if you wanted. I usually bring them down one at a time. So I drop down that next term, and then, or the next digit, and then I'm basically going to repeat this. So now I'm going to say how many times does 5 go into 22? 4. And we're going to go through these steps again. Multiply. Subtract. Drop down. And repeat. So we keep doing that until we like basically have no digits left to use. 5 goes into 31 6 times. So, there's a few different ways we can write this. So the first one is writing it with a remainder. This is like when you were back in whatever grade that was that you learned. I don't know when elementary school teaches certain things just because I feel like it's different depending on the school. We write it like this with a little r. So 1,446 remainder what? The quotient remainder theorem is when we wrote it kind of the long way, that I basically said this answer, this 7231 equals the 5 times the 1446, and then we need to add 1 to it. So it's kind of just a way to show where this all came from. That's that quotient remainder theorem version. And then the last one is actually rational form, which is kind of strange. You might not realize that this works this way. It's basically taking this one and putting a fraction in it. It's really 1/5 because 5 was what we were dividing that 1 by, but I couldn't do it anymore. I didn't want to like get a decimal or whatever. So 1,446 remainder 1 is really the same thing as 1,446 and 1/5 because we divided by 5. So that's just another way to write it. And so depending on which way they ask you to write your solution, I just want you to be comfortable with it. So all the different ways are a possibility they might ask you. All right, so we're gonna get into long division, but do you want to break?
Yeah.
No, can we do can we just finish this and then do a break? Yeah, look how much there's left. There's at least
Two examples are kind
Yeah,
of
let's just
long.
do it though.
All right, Garrett said so, so we just do it, Garrett.
out.
No, I meant like, let's just do the break.
Can we just write out these problems?
Becca.
Actually,
You can do it.
Becca's
Let's
really
just do
right
the
because
problem. Let's
if
just
we
do-
get this done, that's,
You got
that
more
means
break
she'll give
time.
us a longer
You got,
break.
yeah, you
Yeah,
got.
a longer break, because then we have more to teach.
Yeah.
Exactly, yeah.
Let's just do the problems.
Garrett, just write it out, you can do it.
Jonathan's the voice of reason.
Garrett, save your tears for the
You
pillow.
can do it. No problem.
Can we just do
Just one.
One and then a break?
No, just do both.
Just do both. If we're gonna
Garrett
do
can
one.
get a break and just copy someone else's.
Can we just have 2 breaks?
No.
Why not one long?
Yeah, why not one break?
I would just do.
All right,
3 breaks?
yes. 3 breaks right in a row. All right, guys, so we're going to divide this using long division. Now, when I wrote those steps off to the side, so like on the other page, I had written divide, multiply, subtract, and drop down. Now, when you're a little kid, you didn't actually ever, no one ever wrote these steps out. They told you and you practiced it enough that you got it down. When we are now learning with algebra, we need those steps maybe just to remind ourselves what we're doing because this kind of seems kind of abstract and kind of out there. What are you two doing?
Yes, so.
I didn't do these last 3.
Oh my God.
I'll still focus on the break.
All
We
right.
can keep going without them. They can catch up.
Now I'm worried about Stone though, and he was actually paying attention.
Nah.
All right. Okay. So one of the things you might want to consider doing is kind of having a little thought bubble over here. So if you remember when you a little cartoon thought bubble here, what we're thinking here is I'm thinking I'm dividing 4x to the third by 2x. So I'm just looking at these first 2 terms that I'm going to divide right now. I'm kind of ignoring the 1 for right now. So we're dividing those first 2 terms. When I divide that, this is what I'm thinking. 4 divided by 2 is going to be 2. X to the third divided by x is going to be
X squared.
x squared. Now, I realized I should have I'm going to write 2x squared up on the top. Now, this next row is going to get a little dicey, and I'm going to suggest that you are careful about how you line things up, because when I go to multiply this is going to get multiplied to both of these, but you're going to notice that I'm going to have like a missing, does anyone see that I'm missing? Yeah, the 2x squared's or the x squared's kind of throwing me off, it's not there. So you're going to kind of want to shove that in the middle here, so we're going to have to kind of do a little bit of weird spacing here. So sorry if you're a total line things up person, you might have wanted to leave like a little space here. So we're going to multiply this back. So 2 times 2 is 4, and then x squared times x is going to be x to the third. Those are going to cancel, and that should always happen, so those should always match. 2x squared times 1 is just going to be 2x squared. So I'm going to put this right here, kind of try to hug it in there. So I multiplied. Now I'm ready to subtract. And I'm going to put parentheses around here so you remember to subtract both parts of this. So this first part should cancel, that should always be the case. But this second one, like in this one, there's nothing for this to subtract from. So it's basically like 0 minus 2, so it's going to be a negative 2x squared. So take a minute to make sure you're okay with where that came from. So there's like nothing with the x squared, so it's kind of on its own, it's its own term. But it's negative because of the subtraction. But now I'm ready to drop down my next one. You with me so far? Okay.
Yeah.
Now we're going to repeat. So I'm going to switch colors just so you can see what step I'm on. So I'm back up to the top. I'm ready to divide again, but just like we divided in long division, we're no longer looking at this top row. Now we're looking at this new row. And again, if you need a little thought bubble, I'm dividing this by this. So it helps to kind of do that scratch work on the side. That's why we did the warm-up we did. What do I get there? Negative x squared, negative 1x squared, negative x squared. Okay. Oh no, negative x, right? Sorry, not x squared. Sorry, I'm glad I didn't get too far with that. Negative x, negative 1x is fine. Sorry, x squared divided by x, it just becomes an x. Now we're ready to multiply. So this one, now this green one is going to get multiplied to those two. Now be careful on the subtraction step, because now we have a couple of negatives here, but I have to subtract this row from the top one, so they're actually both going to change their signs. So they're both going to be opposite. So this is going to cancel. It'll be 7 minus a negative 1, so it'll be 7 plus 1. So it's going to be 8x. And then drop down. Yeah, I'm a math teacher, so I like it, but I'm glad to hear that.
Like in algebra too, like when we were doing like this, like no one liked doing like the actual like long division. Like this is how like I understood it.
Yeah, it's
like,
I don't know, it's somehow satisfying.
He taught it like a different way too, like a little like I don't know.
Oh, do you do synthetic?
Yeah.
We're gonna do that next.
Like I
yeah.
so that's not
that was not your jam. You're like, give me a
I mean, I
long.
could do it, but like I just didn't like it as much as I.
Yeah. That one I never felt confident about, so I'd always do long division to check it.
Yeah,
so.
me too.
All right.
I like algebra.
Is this okay? You're okay?
This is good.
Okay.
I don't want to do this.
Okay.
Lost in that so much.
I was actually kind of looking forward to this chapter when I saw it. Like I was like,
That's like actually
all right. This is our last little thought bubble here, because 8x divided by 2x is going to be 4. The x's will cancel. Again, we have to multiply that back. Now this one initially, oh no, it will be no, it's gonna be, oh no, it is gonna have a remainder, right? Because this will cancel, but -4 and -4 is actually -8. Initially I was thinking it was all gonna cancel, but we do end up with a remainder here. So depending on how they want us to, sorry.
Oh, you have to.
Yeah, you have to subtract it.
Oh.
You go more negative. Yeah, I kept second guessing myself as well. So depending how they want you to write your solution, they might just ask for the remainder. The remainder would be -8. They might ask you to write it as a fraction, so then you'd write plus like -8 over what you were dividing by. Again, this is just the remainder if you wanted to do it that way. Just kind of depending on what outcome, like what way they want you to write it, because we can kind of write it those 3 different ways. Okay.
Wait, so would this be like a fraction?
You just need to either write like plus or minus in front of it. So you could write just minus that, or you could write plus and negative. Yeah, I wrote it up on the top up here. All right.
Oh, I didn't see that.
No, it's okay. Garrett's dying for a break. You guys.
Okay, no, we can do this last problem, Garrett.
Yeah, chill.
I'll leave it to it for you then. We really need to break that down.
Alright, let's go.
Let's go.
See, the faster we move on and the faster we do this, the faster you get a break, which is a longer break. Yeah.
Really? Is that how it works?
That's how it works. And she's nothing else to teach us how to just follow.
Yeah, I can't make up new stuff now. What are you doing yourself? You're watering your eyes with
Water in your eyes.
sparkling water. Okay. So this is a big one. It's a big one. Now, are there any missing powers of x we want to leave a little place for?
No.
No.
No, there's not. So we don't have to worry about.
So are we just doing the same thing we did?
Yeah, this is just a big one.
Sure.
It's a big one. I couldn't stop laughing at Abby's fish last night.
Yikes.
And then she had him like swimming, like.
That was so much, however.
You did a good job with the lines.
Thanks.
Yes.
When I got home, Peyton said there was one questionable call that he thought I gave to you, the random like.
Whoa.
It was a little questionable tonight.
There was one
where she
you had
smashed
a-
it
you
in
had a
bounds
double
and,
play.
like, I know.
And then didn't call it.
And then I was like,
I
thinking
saw
about
you.
it.
You were like,
I literally looked at him, I was like,
Okay.
are you gonna call my double?
that's why you gotta just play it off like you didn't do it. Even if it was
So,
obviously,
okay,
you should-
this
you
is
gotta
like
argue.
the instant replay in the NFL though, that play. So he let it play out, and he said had the point gone
To us.
to us, then he would have called us like Mr.
But it
Koenig
works,
and I.
yeah.
Like a
Since
replay?
it fell the way, yeah, it fell the way it was supposed to, kind of like a fumble or something. Like he's like, but if you
Oh,
just
like
stopped
they
it,
let it play out.
yeah.
And then they
And then-
review it.
Yeah, and he kind of was like, he's like, he thought she hit it twice, and like, but he was like, if I stopped it then and I was wrong, then you just wrecked the play, and like, so he like let
so
it keep
like
going.
A fumble.
Right, and it's like, it ended up falling the way it was supposed to anyhow, so he just let it
Yeah,
keep
they don't
going.
want to
So,
play.
and I kind of, and so like Mr. Wilderman asked about it afterwards. He's like, was I supposed to like wave my flag or something? Because he was kind of, like, we kind of both all looked at each other, and even the other ref looked, and yeah, so. All right. So again, this is just a bigger, longer problem. Lots more digits to work with here. Again, if this little thought bubble is helpful. If you don't have to do that, don't feel like you have to. I like to line everything up. So since this is going to be a 2x to the 4th, I'm going to put it right in that spot. I'm going to kind of like keep everything lined up, but that's just my preference there. Then we multiply this back. It's really easy to go awry on this, so once things start getting weird, stop yourself if needed. biggest probably mistake is not subtracting when you should. Negative 20 minus 4 is a negative 24. Do you guys agree?
Yeah.
Wait.
I messed
thought
up too. I messed up. Did you get like
I thought
before
you were-
16?
I thought you were supposed to not like pay attention to this.
But we are paying attention because they line up this time. The last time we did it, so yeah, good question. So Stone thought we were supposed to ignore it. We did that last time because the two didn't match up. They weren't like terms. Now they're like terms. Now we do need to subtract them. So I guess I'm glad we're doing one like this. So since they're both x to the fifths, we can put them together. We
Okay.
only didn't do it last time because they weren't the same exponent. So
Would
they
you
weren't
say
like,
that it's more likely for them to line up or for them to not line up?
I'd say line up, but if they don't line up, one of the things I would have done on the last one, had I thought to mention it, I actually would put like a 0x squared in there like as a placeholder.
Oh, okay.
So I write that just to kind of like make sure I don't forget that that's like, that was supposed to be there. So that's kind of a good strategy, like if there's a missing power of x. That makes sense. All right, are we okay now?
Yeah.
Together again? Okay. So now we have to divide this one by this one. That's a negative 8x to the third. Be really careful about signs. Now again, make sure we're subtracting here, so negative 7 minus 16, so plus 16, right? Oh yeah, so yeah, you have a positive. Okay. I was nervous. I looked quick and I thought your 9 was negative. I was looking at the line below. Yeah. All right, ready for our next round here?
Is it common for them to be this long?
I think I just grabbed a long one just to do it, but yeah. Just because there's so many places to make mistakes. So this is 3x squared. Multiply back. So 9 minus 6 is going to be 3x to the third. And you basically have to keep doing this until you can't divide anymore. Or you run out of paper.
Yeah, literally.
Alright.
I'm gonna be really angry.
X the first, sorry. And one place to watch, like I noticed I went wrong because it wasn't matching. Like I was multiplying and I was like, wait, that's not the same. So I kind of watched this. These first two should always match.
You have to put X in first, you can just put
You can just put X. Right, I'm totally running out of
Wait,
space here.
wouldn't that be
You're almost
3x?
done. Yeah, there's 3X.
It's 1 though times 2. Right? You like forget how to multiply when you're doing something this long, right? Alright. So this ends up being negative 1 minus 2, so a negative 3. This one's a marathon.
Yeah.
I'll type it.
Totally out of space.
It's not even
I'm gonna check the weather app.
I think it's supposed to rain today. I don't know if it.
What is?
Oh, it's. No, it's not.
That's just
Yeah, so our next one here, it's a negative 3 divided by 3, so it's going to be a negative 1. When I go to multiply that, I think everything cancels, right?
Yeah.
Let's go.
So everything cancels, except there's still
There's a 7.
this 7 that never, so 7's just our
Remaining.
remainder of that.
Let's go.
So it's going to be a remainder of 7.